All right, so let me solve this question as you know requested. We want to divide x cube. I have to increase this a little bit. While I do that, I'll also have to increase the thickness of my pen also a little bit. All right, so I want to divide x to the fifth power plus 2x to the fourth power minus x cube. That should be written properly, minus x cube plus 2x squared plus x minus 1. I'm dividing this by x squared plus 1. The first step to take is to take out the highest power of x, which is x to the fifth power, x raised to the power 5 divided by x squared. X to the power of 5 divided by x squared is x to the power of 3. Just subtract the powers. 5 minus 2, you have 3. Write that quotient here, x cubed. X cubed times x squared is x to the power of 5. X cubed times x times 1 rather is x cubed. Then you subtract. Okay, in subtracting these particular expressions, remember we are subtracting or adding like terms. So x to the power of 5 minus x to the power of 5 is 0. 2x to the power of 4 do not have a like term here, so that will come down right here. 2x to the power of 4, it doesn't have a like term in this term, in this expression, so I'm going to bring it down. Then since x cube and x cube are like terms, I'm going to add those two together. All right, so minus x cube minus x cube, that will give minus 2x cube. Did you see that? Minus x cube minus x cube, because there's a minus outside here. Minus times plus is minus, so that will give minus 2x cube. Then we bring the other terms down, plus 2x squared plus x minus 1. So those are the terms that we've brought forward. All right, next step is to pick the first term again in this new expression, 2x to the power of 4, 2x to the power of 4 divided by x squared. 2x to the power of 4 by x squared is 2x to the power of 2, because 4 minus 2 is 2. Write that here, plus 2x to the power of 2. Now we multiply 2x to the power of 2 by x squared. That will give 2x to the power of 4. 2x to the power of 2 times 1, that is plus 2x to the power of 2. Again, we subtract these like terms. All right, so 2x to the power of 4 minus 2x to the power of 4 is 0. 2x to the power of 3 do not have like term here, so I'm going to bring it down. Just take it with the sign, minus 2x to the power of 3. Then we'll move on to the one with the positive, to the power of 2, which is 2x to the power of 2 minus 2x to the power of 2, that is 0, right? And then we bring the other terms down, plus x minus 1. Are you following? With this, we go through the process again. Pick the first term of this new sum or new expression, which is minus 2x to the power of 3 divided by the same x squared. So when we perform this division, we would have minus 2x, because 3 minus 2 is 1, so that we have minus 2x, and that will be written up here, minus 2x. Okay, now let's multiply minus 2x by the entire expression. Minus 2x times x squared will give minus 2x to the power of 3 minus 2x times plus 1, that is minus 2x. Again, we subtract again. When we subtract, we have minus 2x cubed minus minus, which is plus, minus 2x cubed plus 2x cubed gets 0. And since these are like terms, we can actually add them up. X minus minus, which is plus, so x plus 2x, that is going to give us 3x. And then we bring the minus 1 down. And at this point, 3x is a lesser term compared to x squared, because x squared has a higher power of x than 3x, which means we can perform further division. And here is going to be our remainder. So it means that when we divide the dividend, let's call it f of x, because it's long, I don't want to write the entire dividend, by x squared plus 1, which is the divisor, we obtain the quotient x cubed plus 2x squared minus 2x plus the remainder. So here's the remainder, 3x minus 1 all over the divisor, x squared plus 1. So this is the answer you get when you divide this quintic powered degree quintic polynomial by the quadratic polynomial. We have a cubic polynomial with a linear remainder, polynomial of degree 1, the remainder. And that's how to perform this. I hope this helps and I hope you understand this. If you have any question, please let me know. Thank you.